gateways and other things, broken cables that are very good in data corrupting data. And we can check that. And with a RAID, we can actually, if we have a good copy, we can actually repair that sometimes. As I said, we have built-in RAID support for RAID 0, 1, 10, 5, RAID 6. Then there's cool features for backups, and some social networks also use that for their container service and system updates. We can just send whole file system trees or subtrees of the file system via the network while piping it through SSH or something, which is pretty convenient if you have a fleet of some thousand CentOS servers. So, next thing for zone block devices. Is there everyone aware of what zone block devices are in the room? Everyone? Anyone not from WD who is aware of zone block devices? Okay, there's some. So block devices have smaller zones of append-only regions, kind of like a lot of stacked tape drives. So you can randomly read, but you can only sequential write on these zones, and all these writes have to start at the write pointer. And when the zone is full and you don't need the data anymore, you can just issue a zone reset. That rewinds the write pointer, and you can redo it, which is quite convenient because then you can pack more data into a HDD platter or need to do less garbage collection on an SSD. There's like a small diagram to show how this all works. Like, I got all the zones, and there's the write pointer position. You can only advance it or completely rewind it, like tapes in the good old days. And with that, another cool feature got introduced with the NVMe CNS standard, which is a zone append. It's kind of a nameless write, where you only specify for the I/O, there's the zone number, I want to have it in there, submit it to the device. The device does all the placement at the position of the write pointer and reports the position it wrote the data back to the host, which is like what the allocators in the file systems are doing anyway. So the allocators are trivial, like 20 lines of code now. And because it was not specified in SCSI and ATA, Linux needed to emulate it because we wanted to use it in the file systems, and so we need to have a generic way. I did an emulation in the SCSI driver that went in 5.8, and then Damien redid it and wrote a completely generic emulation that went into the block layer in 6.10. And another really nice, nifty feature with zone append is that you can go high queue depth. So if you don't have zone append, you have to make sure there's no reordering of your data. So you have to basically have a mutex around every data submission, so only one context can submit the data. With zone append, you don't care. It's like that zone, write the data, tell me where you wrote it. I can then afterwards build my metadata to find it again. So we can just go whatever queue depth we want. Every process can do submission. With all that, BTRFS looked like a good file system to work on some block devices. So the WD team back in the day started with it, and before I joined, and then I joined into that team to help them. And 5.11 merged the basic support. There's a log-structured superblocks, so for all superblocks in BTRFS, because we can't override them, we take 2 zones and have like a log-structured, mini log-structured file system in there to only append it. Then they align the block groups to the zone sizes, and an extent allocator that, just pick zones with enough data, with enough free space in it, and we do zone append for that. In 5.16, CNS support was added because CNS spec wasn't done finalized yet when we submitted for 5.11 and 5.12. And there's some caveats with CNS because the zone capacity can be smaller than the zone size in CNS, so we had to take care of that. And we have to respect some more limits from SSDs than we have for HDDs, so HDDs are way more forgiving. Yeah, and that currently it's in stabilization phase. Like I've just copied that from the slide from 3 years ago because we're still trying to stabilize it. Let's get on to BTRFS RAID. And yeah, that's something people say, like, what's with the Unix philosophy? Like, do one thing, do it right, have the file system, and then have a separate RAID layer, and then have a separate block layer. Yeah, but there's some cool tricks you can do if you actually have the RAID in the file system. Because, as I said, data corruption somewhere on the line, on the drive, whatever. HBA is doing stupid things, or memory doing stupid things. Like most of the errors we see in BTRFS are bit flips in memory. We can actually see that. We do have the checksums. If it's just some transmission errors, we do have good data and bad data. We can find which is the bad data, which is the good data. Can repair the bad data on disk. It's handy. And this applies for both the data as well as the metadata. I think metadata checksumming is now like all file systems, all respectable file systems do, but data checksumming, I think it's only BTRFS and BCacheFS probably, because BCacheFS, ZFS. I meant file systems in the Linux kernel, not copyright violations. I'm not a fan of CFS, I'm sorry. And then to be able to do RAID on zone block devices, I added a new tree to just like have the metadata for the RAID, because the normal RAID on BTRFS was like expecting data to be written on both drives in the same place at the same offsets, which obviously doesn't work if you use zone append write. So I had to come up with a solution, and yeah, we are using 13 or 14 B trees in the file system. Just why not add another one? Because we can. We have a huge amount of data amplification anyway. So for metadata, we can still do sequential writes because we actually have to write that QD1. That's why we only need it for data. The initial support was merged in 6.7 for RAID 0, 1, and 10. Then I wanted to start parity support RAID 5, 6, and some generic M plus N parity. And yeah, that's where the last presentation was 3 years ago, here. And then, yeah, different work came, and I got distracted. Yeah. So then someday I finally got some time to to go back to that. And as a reason why we might want to do like zone block device RAIDs on host, like that particular host in our lab has 58 drives of, I think it's 16 terabyte drives. So a MakeFS BTRFS will give you a whooping 800 terabyte file system, and that's not even the big drives. So we could go to a 1.5 petabyte file system with newer generations of drives easily. And you might want to have some kind of redundancy and erasure coding on that, not to lose 2 petabytes because of me having a bug and destroying all your data. So for the Stripe tree, the metadata looks like this. It's keyed by the logical address, or the address in the logical address space of the file system, and the length. And we add an extra 16 bytes per drive, which I think it's not too bad. So for a 3 data, 2 parity RAID, like a beefed up RAID 6 with an additional data drive, it's only 80 bytes per extent, which still fits 51 nodes of the B tree in a single sector. So with like a 2 petabyte file system, come on, it's okay. So there's the mapping of the file extent item. And last time I presented this, there's encryption in that. It's an unused field. I'm sorry, but it is what it is. So there's the disk byte number and the number of bytes goes into the key that we're using for the tree search, which then points us to the extent, which only is a container for some RAID strides that give us the device ID, on which device the stride is living, and the physical address. That's the stuff that's already working. It's in experimental. It works relatively reliable on zoned devices, but on non-zoned devices, there are caveats. Let's call it that way. Just got a bug report 3 weeks ago from some Genti user trying it on a normal device and totally exploding, so I need to get back to work. So, back to the on-disk format. Let's normal Stripe tree on-disk format. And when we're doing parity RAIDs of any kind, like RAID 5, I just thought, like, yeah, why not add a key for the parity, different key type, and the parity is just another data stripe anyway, so it'll then look like this. Here's an example. Like, here's your normal 2 data stripes, and there's the parity stripe. The data stripes are 64K. The parity stripe is 128K because it covers both of these 64K stripes. And for substripe size writes, we can just 0 pad it. So no big deal. Read modify write, or like the read modify override part is not done yet. Should work. Let's be fair. It should work. Like in-memory representation, I do have like data structure, caching, all the stripes, so we can wait for a stripe to be finalized in memory before we write it out, and then before we do all the splitting according to the disk limits. And after the data stripes and the parity stripes are written to disk, we update the metadata that fixes the write hole problem. So either you got your old data or your new data, but not the weird states in between that happen on power loss with a lot of RAID 5 implementations that didn't have any journaling or UPS backups or NVRAM or what else. So as an outlook, I really promise to one day finish that. It's not going to be the next GNU herd. Yeah. So, any questions? There's Linus and I think Matthias. No? No question?
Yeah, maybe a bit of a, this is not a zone device seminar, but where, I mean, those devices are very accessible to you guys working over at Western Digital, I guess, but do we see them out in the open or are they just in the data centers? So will I have them in my NAS at home? Or?
Send email, you can send calls.
Yeah, so like mass deployment, is it going on? Is it like how much of the world's data is on zone devices now and so on? That's
like,
my big question.
Like 80%? Nah, but 80% is on HDDs. That was what? How much is it on zoned? 50? Okay.
I mean, so the half of the world bits are in SMR. We just don't know it, pretty much. So it's just that it's not being talked about, but it's deployed by.
More than half is.
I know, but I didn't want to, oversell it. But it is not talked about because it's the hyperscalers and that they're just buying immensely amount of drives. But it is used insanely much, but it's like no one talks about it, like on the consumer space, because they're afraid of frightening the customers. Like with SMR, we remember all the great news when there was like SMR drives like trickled into the consumer, and that wasn't particularly fine, so that scared a little bit. But I think, I mean, it would make sense to have SMR drives for Synology and Knapp and others. So it'll something that is being thought of that we can do.
There's a substantial amount of Chinese BTRFS users that somehow got hold of SMR drives because they fell off some truck somewhere in some factory. And they're very good QA people, actually, because we don't need to pay them. And they find all kinds of interesting bugs with their interesting workloads. Like when all the Gia coin thing happened, that was the best QA.
But there is, I mean, it is purchable. I mean, you just call up WD or whoever, and you say, I need 1,000 drives, and the account manager will be like, yeah, there you go. So it is available, but you can't go in the store and buy them. Yeah.
I'm just wondering as well with these drives, since you move the write pointer, what happens if you deadlock or crash in between? So you move the write pointer on the zone, and you never get the report back, and you don't know what the data is there. So you have to some way know where the data is or not.
Yeah, on mount we do check the write pointers, we do check the metadata,
okay. So
and then just refuse to mount like, nope. Which is especially for RAID configurations, because we have to check all the drives, all the write pointers, make sure they're all aligned.
Yeah.
Otherwise, yeah, all hell breaks loose.
Okay.
So, another question?
Yeah, it feels everyone knows what the benefit of this zone block device, but I want to ask this like a stupid question, perhaps. Like, what we gain from this zoning?
Capacity.
It's a better capacity, mainly.
Capacity.
Yes. Okay. So
It's around 20%, 80-90%.
Mostly capacity for the hard drives and less garbage collection for the SSDs.
No more questions? Ian wanted to know when will it be done? He's being annoying.
I don't want to answer that question. maybe, hopefully.
What will happen with the wearing of this kind of zone handling? Is it this zone when you're running on some solid state disk? How do you handling wearing?
What all the wear leveling has to be done by the host. Oh, the drive. Sorry. Sorry.
But it's sort of you let the hardware do all the things.
Yes.
I don't know what. Huh?
Maybe we can invite Damien next year, and he can talk about all the internals of hard drives and how, when you write to it, it's not actually writing the data where you expect it to anymore, and all the fun stuff about that. I think that would be interesting, Hans.
Yeah.
Oh.
All right.
Okay.
Thank you.